Hey guys, welcome back to the Former Farm Kid channel. Today we are looking at an easy way to remember how to set up our ratios for geometric mean calculations. Sometimes teachers will allow students to bring in, say on a note card, certain formulas, rules, those type of things. Sometimes teachers give them to you on the whiteboard in the front of the classroom. And sometimes they don't do any of that. They expect you to just know how to do it. So when dealing with geometric means, and let's define it here to start. Geometric mean is the length of the altitude. That thing's an altitude, that thing's an altitude, that thing's an altitude. The length of the altitude to the hypotenuse of a right triangle. These are all right triangles. And just as a refresher, the longest leg is the hypotenuse. The length of the altitude to the hypotenuse of a right triangle is a geometric mean of the lengths of the segments of the hypotenuse. Well, here's our hypotenuse, and I've circled varying segments of all those. So in other words, a geometric mean is a number b that lies between two positive numbers such as a and c, such that the ratio of a and b is equal to the ratio of b and c. If that is true, then our geometric mean between, say, 1 and 3 is not going to be equal to the arithmetic mean. And you might remember how we do that. We just add up the totals, 3, 2, 1, and then we add up and we divide by the number of constants there are. In this case, the arithmetic mean would be 2. The geometric mean for the same three numbers, let's say we don't know b, but we know a and we know c. So then to solve, b is set up twice in our ratio, and then a and c would be set up like this. So therefore, we cross multiply. So b times b is b squared is equal to 3 times 1 is 3. B is equal to the square root of 3, or approximately 1.7. So as you can see, the geometric mean must always be somewhere between the two outside numbers, basically, of the three. So now, back to the real subject of today is, how can I remember these three and their setups to solve for any one of the four legs? So take note. If you want to, stop the video and copy these three triangles. They are right triangles with altitudes drawn into them. The red leg is the geometric mean leg that we are going to solve for. All right, so hopefully you have those copied down. And notice, I started with triangle, they're all ABC. I kind of went from top, middle to bottom, so that they're in the correct sequence. Notice this triangle and this triangle, as far as the legs that make up the ratio, are the opposite of one another. So I would want to draw this triangle first. Basically, it is the little over the big. This one is the big and the bottom little. Notice the mean leg touches both of them, just like up here, touches both of them. You just will have to probably just remember that on my first one, the little one is touched by this line, just like down here. This line touches the little one and the big one and the big one. When I'm saying little one, big one, I mean legs. So these two are basically opposites of one another. The line moves from here all the way down, and again, the line keeps doing this for the mean. That's why they're in this sequence. So it starts with touching both of them. This becomes our mean, so that repeats in both places in the ratio. So here we have, it's touching the short and the long. It doesn't matter which one you put in either position here, the results will be the same because we're still multiplying by CB. So up here, my repeating mean is AC. It repeats right here, and it is hooked to the big one, which is AB. There it is right there, and the little one, which is AD. Doesn't matter where you put those. I can put AD up here, and I can put AB down there. It's going to be the same answer because we're multiplying by the same value there. So that's how you arrive, basically, at these two. And then the middle one, the middle mean, touches both of these again, and it's just this leg over this leg, or if you want, this leg over this leg. So again, CD here repeats because that is a geometric mean we're solving for. And then you can write these two legs either way you want to. DB could go up here, AD down there, as long as they're opposite, you're fine. There's no other way to write it. And that will allow you to solve for the leg in red, which is the geometric mean. Next video, we're going to put several problems up here. There is one twist to doing these problems. Normally, we are solving for the geometric mean, the red leg. There can only be 3 because there's only 3 sides to a triangle. Occasionally, we will know the geometric mean. They will give a value to AC. They will give a value to CD. They will give a value to CB. No big whoop. Instead of writing a variable, if we know the number, we're just going to fill that variable in with a number or value that we're given. So we would have 2 values here that would be the same. Here the same, here the same. And then we would just go ahead and solve as we normally would on a ratio. In the next video, guys, I'm going to go ahead and whip up a couple problems here. 2, well, I think 2 would probably be enough. We'll just do solving for the mean, geometric mean, and then doing another one where we know the value of the geometric mean. Okay, guys, any questions or comments? You can put them down in the comments section. Appreciate that. Thanks for watching. Hope this was helpful to you. If it was, give me a thumbs up. God bless. Keep up the great work, and we will see you on the next vid.